All right, everybody. Hope you are doing well. Yesterday we talked about our properties of exponents. Today we're going to look at our properties of logs. So two different things. We're going to expand them and then we're going to condense them. So expanding, we're going to make things as long as possible. Condensing, we're going to make these into one log. So some different rules you need to know for your properties of logs. We're going to let b, m, and n be positive numbers so that b does not equal 1. So the product property, I got log base b of mn, m times n. I can add those together so I can split it and add them. So log base b of m plus log base b of n. Quotient, when I'm dividing just like exponents, division becomes subtraction. So I got log base b of m minus log base b of n. And then the power property, so I got log base b of m to the n power. The key to look at this is that n, if I got an exponent, it's going to get kicked out front, and that's where that comes from. So those are your three main rules for logs. So expanding, we're going to be breaking into multiple terms. Each term is going to be as simple as possible. So the goal for this is to have as many logs with only one number and variable inside of each of them. Condensing, we're going to put the pieces back together. The goal is to only have one log with as much stuff as possible in there. So let's look at a few of these and we'll go from there. So here, what I like to look at here is this is a multiplying and this is divide. So I'm going to go ahead and split. Anything I'm multiplying up top is going to be a positive one. Anything in the denominator is going to be a negative one. So I got log base 3 of 7 plus log base 3 of x squared minus log base 3 of y. So I can take that and expand it. So I'm taking that one log and making it into 3. So everything up top, I got a 7 and I got an x squared. So that takes care of my top. That's the two positive ones. And then I got a minus because that's in the denominator. And then I want to look, any exponents are getting kicked out front. So my final answer is going to be log base 3 of 7 plus 2 times log base 3 of x minus log base 3 of y. And we are done. All right, let's come over here to C just because I like to go left to right. Natural log, same rules apply. So I'm multiplying here so I can split these up. So I have the natural log of x to the 6th plus the natural log of y to the 3rd. And then exponents are going to always be kicked out front. So I got 6 times the natural log of, yeah, that's pretty bad. 6 times the natural log of x plus 3 times the natural log of y, and we are done. So once again, just kind of a quick throw in the side note in here. Remember natural log base, if I write the natural log of x, remember it automatically has a base of e if it's not written. Just throwing some prior knowledge in there for you. All right. It's the same thing, 7y cubed divided by 4x squared. So I'm going to go ahead and split this up. Remember, we're multiplying here, so these are two separate logs. So watch what we do here. So I got log of 7. It's a log base 10, but I'm not going to write that every time. Plus log of y to the 3rd minus log of 4. And then I'm going to also do a minus log of x squared. Instead of having a minus a whole set, since it's in the bottom, it's this negative log. So we are going to subtract it. All right, now let's deal with the exponents. So kick those down, kick those down. So my final answer here is going to be log of 7 plus 3 log of y minus the log of 4 minus 2 log of x. So once again, this part right here, the shortcut is just to make them all negative, but the long way would have been subtracting the whole bottom. So log of 4 plus log of x squared since it's multiplied. And since I distribute that, that's why I can come down here. That's just a side note. That's why I just consider the whole bottom negative and we're good to go. And everything is flat. There's no exponents, no nothing to go here. All right, last one. All right, so let's go ahead and simplify this. So I can go ahead and distribute this. So that gives me log base 9 of 3 power of a power I multiply, so 3 to the 12th over 7 to the 4th. Let's just leave it like that. So I get log base 9 of 3 to the 12th minus log base 9 of 7 to the 4th. Exponents get kicked out front. So I get 12 log base 9 of 3 minus 4 log base 9 of 7. And we are good to go. All right. If you got questions, please let me know over expansion. So that's what expansion looks like. We're taking a small single log or natural log and expanding them into as many pieces as possible. So now we are going to look at this in reverse. So we're going to condense the logs here. So we're going to do this just backwards. So any number in front, I'm going to bring those up first. So I got log of 2 plus log of 3 cubed minus the log of 9. And then if it's positive, it's going to go up top. If it's negative, it's going to go on the bottom. So I got log. Let me learn how to write the word log. So 2 times 3 to the 3rd over 9. We can do that. I'm okay with this. If you want to multiply those together, 3 to the 3rd power is 27. 27 times 2 is what, 54. So you could keep going, and you get log of 6. But right now I'm looking for what's in the box. It's getting everything into one log. And then if you want to simplify, since they are just basic numbers, you're more than welcome to. So 3 times 3 is 9, 9 times 2 is 27, 27 times 2 is 54, and 54 divided by 9 is 6. So you could. Can't do it with variables though, so I like to throw variables in there. All right, so here I'm dividing by 3. So remember, that's the same thing as saying 1/3 times the natural log of something. So that's going to get kicked up. So I got the natural log of z plus the natural log of x to the 1/3 plus the natural log of y to the 1/3. They're all positive, so they're all going to be up top. So I get x to the 1/3, y to the 1/3 z, and I'm done. I just like to put them in alphabetical order, but you don't have to. So move those coefficients up top as your exponent first, and then you can condense them and combine them into one log. All right, let's look at this one. So I got a number out front, so that gets kicked up first. So natural log of 3 plus the natural log of x squared minus the natural log of y. Now, if it's positive, it's up top. If it's negative, it goes in the bottom. So I got 3x squared on my positives, y is my negative, and we are good to go. All right, same thing with z. So let's rewrite it. So I got log, base 9 of z plus log base 9 of x to the 1/2 plus log base 9 of y to the 1/2. We talked about that in D before. So this is the same thing, once again, as saying 1/2 times the log of x. So that's going to get kicked up. So now my final answer here, I got log base 9, everything's positive. So x to the 1/2, y to the 1/2, z. And we are done. All right, the last one. If you want to pause it and get to work, you're more than welcome to. So coefficients gets kicked up. So I got log base 6 of u squared minus log base 6 of v to the 8th. If it's positive, it's up top. If it's negative, it's on bottom. And we're good to go. So condensing, if we look at the difference here, condensing, all of my final answers just have one log or one natural log. So we're taking a bunch of stuff and condensing them into one. So you need to be able to go from expansion to condense or condensed to expansion form. All right, last thing we need to look at here is something called the change of base formula. This allows you to use a calculator, a basic scientific calculator, to solve logs if you have a different base. Basic scientific calculators only use the base of 10. So we need a way to convert it. If you have a graphing calculator, you can hit the math button and scroll all the way down to where it says log base, and you can actually type in bases. So change of base, it's the log of the regular one divided by the log of the base. So here I got log base 6 of 11. So change of base would be log of 11 divided by log of 6. And that's how you would get a solution. So I can do log of 11 divided by log of 6 on a calculator, and you get 1.338. And that's how you would evaluate it. Once again, if you hit math, you can actually hit the up arrow, go down to where it's A. You can actually type in the base and the number. If you need help with calculators, let me know. But this is how you can evaluate a solution. So this change of base would be log of 26 divided by log of 16. So log of 26 divided by the log of 16, and you would get roughly 1.175. I would highly recommend trying these in your calculator to make sure you're getting these same solutions. And then log base 5 of 13, I just rewrote it. Change of base would be log of 13 divided by the log of 5. Log of 13 divided by the log of 5, and you get roughly 1.594. So we are going to use that a lot moving forward solving. So make sure you know how to use your change of base, that you can expand, and that you condense logs. So I hope you have a wonderful day. Make sure you go practice, and I will talk to you soon.